In class today, you did a little bit of exploring and you figured out some things about parallel and perpendicular lines. So this isn't going to be a full lesson, it's just going to be the highlights, what you really need to take out of what you learned today. And I would write notes on this. So here's our 6.6 summary on parallel and perpendicular lines. So parallel lines, those are lines that never intersect. And what's important to know about parallel lines is they always have the same slope. You also learned today that they have different y-intercepts. If they have the same slope and the same y-intercept, then they'd obviously be the same line. They have the same slope and different y-intercepts. Perpendicular lines, those are lines that meet at right angles or at 90-degree angles. And they always have slopes that are opposite reciprocals. So here's an example of some perpendicular lines, and their slopes are opposite reciprocals, which means, like if the first one has a slope of 2/3, okay, the opposite of 2/3 is negative 2/3. The reciprocal of 2/3 is 3/2. Put those both together, it's negative 3/2. Those are examples of opposite reciprocals. And they should multiply to equal -1, if you want another way of looking at it. Okay, if you can solve these next set of problems, then you will be good to go for the most important things of parallel and perpendicular lines for this unit. Okay, so the first thing I want you to check are the following pairs of lines parallel, perpendicular, or neither. So to do that, we want to check out their slopes and maybe their y-intercepts. That could or could not be important depending on what type of line we figure out. So slopes here, remember, if they're in y equals mx plus b, you can just do the value of m for the slope. So this first equation is already in y equals mx plus b. Its slope is 3. The next one's not. We could rewrite that, or a lot of you can probably just see what the slope is just from here. But let's just pretend we wanted to rewrite that. It would be y equals negative 1/3 x plus 5. And my slope here is negative 1/3. So obviously these are not the same slope, so they're not parallel. But 3 and negative 1/3 are opposite reciprocals. They multiply to equal -1. So these are perpendicular lines. Okay. So you're going to check out their slopes, see what it is. All right, see if you can do this next one. Y equals 8 minus 9x, and 9x plus y equals 1. So again, I want to check out their slopes, see if they're the same or opposite reciprocals or neither. So this one, y equals 8 minus 9x. I could rewrite that as y equals negative 9x plus 8 if I wanted. The second equation, it's in standard form, not slope-intercept. So I would want to get y alone by subtracting 9x from both sides. And it looks like y equals negative 9x plus 1. So if I check out their slopes here, the first one has a slope of -9. The second one has a slope of -9. They both have the same slope, and if you look at their y-intercepts, 8 and 1, the y-intercepts are different. So these are parallel lines. Okay, and the last one of these, y equals 10 plus 2x, and 2y equals 10 plus x. So in the first one, I can rewrite it if I want, or I can probably just see that it's similar to y equals mx plus b. The 2 is multiplying the x. My slope is 2. The second one, I don't have y alone, so I'm going to divide both sides by 2 in this case. And I get y equals 5 plus 1/2 x. Okay. If I'm comparing their slopes, so my slope is 2 in the first one, my slope is 1/2 in the second one. Those are reciprocals, but they're not opposite reciprocals. So in this case, we'd say that these graphs are neither parallel nor perpendicular. Okay. All right, let's look at 2 more examples. And these would be very typical. You'll definitely see things like this showing up on your tests and quizzes. I'm writing an equation for a line that's parallel to y equals negative 4x minus 1, and it goes through the point 3,6. So I'm going to look, and the first thing I want to notice is what is its slope. It's already in y equals mx plus b, so my slope is -4. Parallel lines have the same slope, so the slope that I want in my equation should also be -4. It has to go through the point 3,6. Since I have the slope and I have a point, I'm going to use point and slope form. And I'll transfer it to slope-intercept form so you can just check if you get this right. But, so it looks like this. Y minus 6 equals negative 4 times x minus 3. That should be an equation that's parallel to y equals negative 4x minus 1, but goes through the point 36. If I want to solve that into a nice slope-intercept form that means more to me, I'm going to go ahead and use the distributive property. Negative 4x plus 12 equals y minus 6. And then I would add 6 to both sides. And I should say y equals negative 4x plus 18. And if I check to see if that really makes it true, my y was 6. I want to know if 6 really is negative 4 times my x was 3 plus 18. Negative 12 plus 18 really is 6. So I probably did everything correct. I have the correct slope and it does go through that point. All right, last problem. So this time, same equation, y equals negative 4x minus 1, but this time I want you to write a line for an equation that's perpendicular to that and goes through the point 46. So again, in that equation, my slope is negative 4. To be perpendicular to that, my slope would be the opposite reciprocal of negative 4, which would be positive 1/4. Okay, so if that's going to happen, again, I'm going to probably use point and slope form because it's easy to write an equation in. So y minus 6 equals, this time my slope's 1/4, times the quantity x minus 4. Okay, so that would be okay for an answer. So again, I'm going to change this into slope-intercept form just because that will be easier for you to check if you're right. And I'm going to do 1/4 x minus 1 equals y minus 6. And I'll add 6 to both sides. And I get y equals 1/4 x plus 5. And if I check it up here, 1/4 of 4 is 1 plus 5 is 6. So it seems all good. This works out. Okay, if you know these things, you are good to go.